So in this video, I'm going to show you how to solve a quadratic by completing the square. So we've already done it using the quadratic formula, but completing the square also works for any quadratic. And it's just a series of steps that you need to follow and it'll work every time. So step one will always be to move the constant term to the other side of the equal sign. So if I have x squared minus 12x plus 23 equals 0, the first thing I'm going to do is subtract that 23 on both sides, so that I have x squared minus 12x equals negative 23. And once my quadratic is in this form, ax squared plus bx equals c, then I can start completing the square. So I'm going to take the middle value, I'll call that my b value, I'm going to divide it by 2, and then I'm going to square it. So in this case, that b value is negative 12, and when I take half of that and square it, well, half of negative 12 is negative 6. And remember, when I'm squaring a negative number, a negative times a negative is positive. So that's positive 36. Step 3 is I'm going to take that and I'm going to add that quantity to both sides. So usually, when I do this, I'll leave a space on both sides to remind myself that I'm going to be adding that 36 in. So let's say I add that 36 in on both sides. On the right hand side, negative 23 plus 36 is just positive 13. And now I need to think about if I could factor the left hand side here. And you'll always be able to do that. So if I'm asking myself what adds to negative 12 and multiplies to 36, well, that's just negative 6 times negative 6. So I could factor this left-hand side into x minus 6 times x minus 6, but I think this might be easier if I'm a little savvy with my exponents to write it as x minus 6 squared on the left side of the equal sign. Now, a quick trick that might help you out there is whatever half of that b value was, that'll always be the same as the number that you see in your parentheses with x there. And when we're completing the square, it'll always look like this, because the idea is that this trinomial right here is a perfect square trinomial, because I can factor it into something times itself. So once we have that, our second to last step would just be to start solving this equation. To undo an exponent of 2 or a squaring, I can take a square root on both sides. What you need to be careful about here is that since this is a quadratic and I need to get two solutions, I need to remember that it's plus and minus radical 13 on the right-hand side of this equation. That's the easiest thing to forget, those two solutions there. So, if my equation looks like this, it doesn't say x equals yet, so I'm not done. So when I add 6 to both sides, I can't combine 6 with the radical 13 because one's outside the radical and one's inside the radical. So I'm just going to leave my answer as 6 plus or minus radical 13. So this represents my two solutions, 6 plus radical 13 and 6 minus radical 13. If 13 was a perfect square, I might simplify a little bit further, but since this is irrational, I'll leave it here. Number 2. Solve for x by completing the square and express your answer in simplest radical form. So in this case, there might need to be some simplifying I do under the radical before I finish. So I'm going to follow those same steps. I'm going to move that constant term over to the other side. And notice how I write my next step. I'm going to leave a space on both sides of the equation to add that b over 2 squared. So when I take my b value, 4, divide it by 2 and square it, 4 over 2 is 2, and 2 squared is 4. So I'm going to add 4 to both sides. My right-hand side is 20, and my left-hand side, when I factor it, turns into x plus 2 times x plus 2, because 2 times 2 is 4, and 2 plus 2 is 4. Now that'll happen every time that you can write it as a binomial square, because the whole idea is once we have it in this form, we can take the square root on both sides to get rid of that exponent of 2. So my next step is just x plus 2 equals plus or minus radical 20. And I'm looking at radical 20, and I'm thinking I might be able to break that down a little bit into a perfect square times a non-perfect square. So remember, if I take that out, radical 4 is just 2. So radical 20 is the same thing as 2 radical 5. So I'm going to continue my work up here. I still have x plus 2 equals, still plus or minus, 2 radical 5. And I'm just going to subtract that 2 on both sides here to get x equals negative 2 plus or minus 2 radical 5. And again, these aren't like terms because one of my terms has that radical 5 there. Remember, to combine radical terms, they both need to have the same radical. So this is as far as I can simplify my answer here. Now for something like number 3, it's still a quadratic, and I could still solve it using completing the square, but there's this issue of this division by 4 here. So I'm not a big fan of working with fractions in any of my equations, so there's a trick I can do to fix that. If I multiply everything in this equation by 4, watch what happens. My first term becomes 4x squared over 4 equals 4 times x minus 4 times 2 is 8. Now, 4 divided by 4 is just 1, so all I'm left with on that left-hand side is x squared. So if you see something in the denominator, multiplying by that number across throughout your entire equation can help fix that so you don't have to deal with the fraction as your leading coefficient. Because completing the square only works if there's a 1 out in front of your x squared. Otherwise, you'd have to divide it out first. So it's not quite in the form we need it to be in yet, so I'm going to subtract the minus 4 over to have x squared minus 4x, I'm going to leave a space, equals negative 8 plus something. Notice that I left the negative 8 on the other side because my constant was already over there. I want my x squared and my x term together, and I want my constant term on the other side. So again, when I take half of negative 4 and square it, that's just negative 2 squared, which is just positive 4. So I'm going to add positive 4 to both sides. So my left-hand side just turns into, well, what adds to negative 4 and multiplies to positive 4? That's negative 2 and negative 2. And my right-hand side is negative 4. So I have x minus 2 squared equals negative 4. Now you should notice the instructions said, leave your answer in simplest a plus bi form. So even before I started this, I'm thinking I might have a negative number under the radical at some point to cause me to get an imaginary part of this. So when I take the square root of the left-hand side, I'm left with x minus 2. And we need to think about the square root of negative 4. I know it's going to be imaginary, plus or minus, because there's a negative under the radical, and 4 is a perfect square. So radical negative 4 just simplifies to 2i. Just remember that it's plus and minus to represent our two solutions. And I'm going to add the 2 over to both sides. So I'm left with 2 plus or minus 2i. So this is simplest a plus bi form because my real part of the complex number is in front, and my imaginary part is in the back. So let's try one more example. So again, for number 4, it asked me to solve by completing the square. And I noticed that I have a 2 out in front for that x squared. So before I can start completing the square, I'm going to divide everything in my equation by 2. Even if they're not all divisible by 2, I'm still going to do that because if I have a leading coefficient of 1 for this x squared, I can always complete the square. Now in this case, it works out because they are all even numbers, but that won't always be the case. So again, if I take that b term, 6, take half of it and square it, half of 6 is 3, and 3 squared is 9. So I'm going to add 9 to both sides. Negative 8 plus 9 is 1. And when I factor this left-hand side, what adds to 6 and multiplies to 9, that's 3 and 3. So I'm just going to rewrite this left-hand side as x plus 3 squared. I'll save myself a step there. I do the same thing where I take a square root on both sides. to be left with x plus 3 equals the square root of 1 plus or minus, but if you're thinking a little bit, 1's a perfect square. The square root of 1 is just 1. So I'm just going to rewrite that as plus and minus 1. So now something interesting happens when I simplify my answer completely. Before, we weren't able to go any further than this, but if you notice, negative 3 and 1 are both like terms. So if I split this up into my two solutions here, x equals negative 3 plus 1, and x equals negative 3 minus 1, I can keep simplifying there. Negative 3 plus 1 is negative 2, so that's one of my solutions, and negative 3 minus 1 is negative 4, so that's my other solution. So in this case, my solution set is actually negative 4, comma negative 2, because I was able to simplify further. So if you can simplify because you have like terms here, always go the extra step.